Okay, thank you for coming. May I help the people who are behind to come a little bit further? It will be nicer for everybody if all the first tables are not empty. So is it possible to ask you to go forward? Thank you. Before beginning the session, I have a follow-up of the last session. So we have been asked by several people, especially a Syrian lady, whether it will be possible to go to, she's here, to enter into the US. So we have said that we are really aware of the problem. Rajiv has done everything he could and very efficiently for having people coming here, even where they are of a nationality that are not completely politically correct here. At least we will do the same. And Mark Cooper has charged me to say that you have US here, but on the north you have Canada, in the south you have Mexico. So we will have plan B if things are not correct. So, but we will make everything we can so each of you can participate into Drought 6. And if I can ask a little bit people to come, and I think we will begin. So, wrap-up session. First, as I said before, we have shortened it a little bit. So the wrap-up session will be 1 hour. So the key point is what Roberto said this morning. We all need to go home asking ourselves, okay, what did I learn? So we have done that in a dual way. So we have 6 early career scientists who have agreed to give their point. So they have worked quite a lot this week. It's self-organization. So I have no clue about what they will say. And they have organized the way it would be. The only constraint is that it shouldn't exceed 5 minutes, with just one exception. One colleague was going to come, finally he could not come, so his message will be carried by somebody else. So how did we choose these people? It was the organization committee who did, the international committee who did that. We tried to have colleagues from private and public sector. Can I? Yeah, it's like that. Yeah, private and public sector from different countries, different disciplines, etc., according to the philosophy of Interdrought. So they will give their point, and then I will take the ball for some points of mine. I have to apologize because not all countries are represented. The process has been a little bit chaotic. We have chosen people, and some people could not come at the very last minute, and especially the Chinese community is not represented here. We tried very hard, and finally it was not possible. So sorry about that, but I think we all are human beings at the end. So self-organization, so you can begin. Well, it's hello. No. I invite you. You have the names on the screen anyway. I invite Vera. Perhaps you can talk from your seat. There is no need of changing. So Vera, the floor is yours. 5 minutes.
I'm glad that I'm here today in Inter.5 conference. Thanks to the organizers for inviting me to this conference, because now I have an opportunity to meet researchers from over 55 countries. And first, as asked, as requested, first I would like to share what I have learned from this conference. because I understood that we had to produce 69% more food by 2040, but in variable climate. It means we have to achieve productivity targets in a climate where we have frequent dry spells and also there is rise in temperature. But I'm a plant breeder and I used to think that we have to employ modern breeding systems and then rapid varietal replacement is key for addressing the issues. But from the galaxy of panelists who have come here and eminent scientists, I learned that we have to have three approaches like adaptation strategies, mitigation strategies. We have even employed new crops and new areas to address the issue of climate change. Some of the speakers have already told that there is success in Kurnool district of Andhra Pradesh of India. That is the place where I am working. There, by giving short-term predictions on weather, they have demonstrated increase in productivity of the crops. It is also a district which has adopted high-yielding chickpea varieties. It is also a place where drought-tolerant groundnuts are being grown. I also learned that system approach and transformational agriculture are also important when we have to address these challenges that we are facing now. And another important thing is I am very much excited about some new areas of research, that is study of exploring water extraction by employing miscellaneous mixtures, then studies of aquaporins. And I am also quite interested to learn that there are new tools being employed in study of soil plant water status like electric resistivity tomography. So all these new areas are quite interesting and useful to us in our future research. But having learned so many things here, but now it is time for us to work much faster and in a precise manner. So for that, what I feel that first we have to define the target environments and we have to define the phenotypes with good traits for each environment and each crop. And most interestingly, what I request from international institutes is that most of the time we are unable to realize the productivity because of the narrow genetic base. So I request the institutes to set up mission mode projects to broaden the genetic base by employing modern plant breeding approaches and also uh, traits germplasm with traits they have to employ, and they should make available diverse breeding material to the national agricultural research system. That is the request that I am putting forth. Not only that, I also request that more products should come out of genomics, because there is vast knowledge of genomics now available and we should see the products coming out of that. And one more interesting thing is I request real-time studies of root growth dynamics, because most of the studies are based on pot conditions. Instead of that, we can have that in simulated field conditions, and we should have real growth studies. Thus, not only that, we have to target variable environments, specifically in environments where changes are much more faster. So the what I feel is we have to make available product or process to the farmers as early as possible. Not only that, to make him realize the benefit of the products, what is important is he should have direct access to the market. So finally, I feel that the fruits of research as well as the increase in productivity realized by the farmer will be remunerative when only we have good policy support. So I feel that we should work in this direction and to realize the fruits of our research. I once again thank organizers for giving me an opportunity to express this.
Thank you very much. I'll pick up from where my colleague has left, and I've outlined my observations into 6 points, 3 of which are mine, and 3 others belong to this colleague of ours who did not make it to this place. It's called Belko from IITA. So I'll start with my 3 points ahead, and then I'll mention his 3 points. Now, one of the points I'd like to highlight was coming from the session we had on climate smart agriculture, where we had lots of discussions from eminent personalities from different sectors, governments, as well as various administration officers, and looking at areas of various ways at which, by which we need to work to be able to tackle issues related to climate change, particularly as it affects agriculture. Looking at water smart practices, looking at energy smart practices, looking at nutrient smart practices, looking at weather smart practices, looking at knowledge smart practices, and that all these together, these practices, if well, implemented, would enable us to work with better precision and approach, I would say, climate-related stresses and of relevant to this particular meeting, drought-related stresses in a more systematic way. And that leads me to the second point, which was basically an observation I made from some interesting presentations, and this particular one from a poster, which was comparing species within the C4 category of plants, and also comparing varieties, or let me say lines that are modified for purposes of drought tolerance. And there are very clear differences between species and then within species in terms of varieties. That means proper selection is not just about the varieties that we're going to use in the field, but also proper selection in terms of precision, in terms of timing, in terms of the agroecologies that we're going to do the production depends quite a lot, not just on the varieties, but also on the crops of choice. Of course, later on, the issues of consumption and utilization are issues to grapple with, but production is something that we cannot underestimate in terms of the choice of particular crops that we're going to handle in those particular semi-arid and dry land tropics. And this leads me to the next point that I wanted to make, that we've done very good, very well in terms of presenting a lot of high-end science in terms of phenomics, in terms of genomics, but I think we need now to put a little more emphasis on translating the high-end science into more of applied science, on how we make use of this knowledge that we've tapped from phenomics and genomics into, plant breeding, and leading these into, the seed systems, agronomic practices that are improved, that take advantage of the science that we've done into a practical application that is of benefit to farmers. Of course, at the end of the day, I believe most of us are in here with the interest of farmers at heart, and not just interest of science at heart. So what I would quote one speaker, the science of discovery should find a pipeline leading to the science of delivery. And then one more point that I would like to make, and now this is not my point now, I pick up points from my colleague, who puts emphasis on capacity building, particularly for the young scientists, that quite a lot of the high-end science that we've been listening to are good, but we need to think in terms of continuity beyond the senior scientists that have been making these presentations. And his particular emphasis is for those scientists coming from Africa, that we need to put a bit more of mentorship and capacity building in these particular areas of genetics, genomics, phenomics, and plant breeding. His second point goes into multi-stakeholder and multi-disciplinary approach to tackling most of the issues related to challenges of drought, like we cannot concentrate upstream on genomics only, but we need to think in terms of what soil scientists would do, extension specialists, policymakers, and public-private partnerships in ensuring that the technologies being developed are actually also delivered. And that leads to my last point, which is again not mine but his, that in conferences like this, where we end up getting very good insights in some of the approaches or modern approaches to tackling some of the challenges of production, we need to think in terms of bringing together some of the policymakers, politicians, CEOs of private sector, people who at the end of the day pick up some of this knowledge and go back and make use of it, particularly in inspiring the youths to make agriculture more interesting, to make agriculture more beneficial to the youth, and they feel like, yes, we need to be more active in agriculture. I hand over to my colleague.
Thank you, Chris. So in my case, this is my first Interdrought conference, and I am really surprised because of the amount of people and also the diversity of talks at different scales or with different species that we listen along these days. Several things that I really liked, for example, the different ways that people are using to attack the G/E interaction through models, through trait response to environment, through a better dissection of the environment in some cases, or the use of QTLs for trying to improve a specific trait at the plant level and in some cases at the crop level, and how those QTLs interact with the environment. That was really interesting. And finally, I also would like to highlight two examples from the breeding talks with really successful results in rice and sorghum that make us believe that finally the QTLs are a good tool to try to improve the crop performance. But I would like to highlight that, in my opinion, we need to have a better environmental characterization, and I'm talking about we need to quantify the drought stress because in some talks we didn't have any detail of that, and I think doing that in a qualitative way it would be more difficult if we want to make any progress in this area, and even more because I think the name of the conference is Interdrought, so it would be nice to quantify these stresses and also to talk about the timing of the stress. It's not the same to have a stress during the vegetative stage or during the reproductive stage. The consequences are always over grain yield, but the impact or the magnitude will be different depending on the moment. This was really well covered this morning, but it was an exception more than a rule, and I think that must be a rule instead of an exception. Another thing that I think it would be interesting or important at least is to try to link the plant experiments when we talk about plants growing in a pot with field experiments, because I saw that there are really nice results at the plant level, but we need to give value to that data, and go into the field, and in order to avoid to be pointless in some cases. And I think, in my opinion, that the way to do that is not difficult. It's quite easy. In fact, it would be improving the collaboration between groups. There are people working at different scales, at the cell level, at the organ level, at the plant level, at the crop level, and even at the model level. So if we say also different species, there are some examples from different species that were really nice. Maybe we can use it in the species we are working on. And I think that we started this meeting, this conference, saying that we are a community. And so if we are a community, maybe we need to start collaborating between each other and not just in the conference. But well, that's all. Thank you.
Thank you, Santiago. What I was impressed by is that when we think about drought, we always think about very dry fields with plants that are suffering from a very harsh drought. But in some cases, what I learned here is that a very little difference in plant tolerance can lead to very large increase in yield at the end. For example, one researcher told us that what we need in many cases is just that the plant would tolerate a few days of drought more than the usual plants cultivated there. So it's a matter of very small things that can at the end make a difference, and it's not always a very harsh drought as we can see on the pictures we have here in drought. It's not always a very severe drought. Sometimes it's just a little drought, and this has to be tolerated by the plants. Some example I saw here in the conference. A first one was the example of plants that saved some water during the vegetative phase and used it during the reproductive phase. And the amount of water saved was really small. It was about few millimeters of rain, and it did a difference at the end. So it was a very small amount. A second example that I noted was on a poster. I don't think many people remind of this poster. I don't even remember its number. It was a pearl millet field, and it was either irrigated or not irrigated, and only 10 millimeters of irrigation allowed to double the yield of this field, and this really surprised me. It's such a little amount of water of irrigation, and it allowed to double the yield of the plant in this field. About the plants that save water during the vegetative phase, we also learn this week that in some cases, when there are weeds, for example, this can be counterproductive because weeds take up all this saved water and the crop can't beneficiate from it. So this leads to my second point, that some plant traits must be associated with proper management practices. And I feel that these management practices were not really discussed thoroughly in this conference, except maybe today, but we mainly told about plant traits, but a little about how to manage these plants, how to manage weeds, and so on. So I think that the experiments we do on drought-tolerant plants should be really precise on this management thing. And even in the fields at the end, very small differences in management may lead to substantial increase of the yield, and at the scale of a plant, it may be quite small, but at the scale of a field or even of a region, it can be huge increase. And I think that, so these 2 points made me feel that agronomic research is really a precision matter. We have to be really precise in our research and in our practices to have substantial benefits at the end. Thank you.
Yeah, hello. My name is Gregor Hummel from Finospex. So thank you, François, consider me being a scientist, and especially a young scientist. Actually, I stopped my scientific career a couple of years ago after my PhD. I think I was not smart enough, then I created my own company. And considering being young, I went to bed very early last night and I shaved a bit my face. So. Yeah, so for me, the 3 days here at first time also for me at Interdrought, it was very, very interesting. And I'm actually pretty amazed about the complexity all you guys are working on. I mean, it's incredible. It's actually pretty fascinating. And on the other hand, and that's what we learned, is that we have actually a lot of possibilities and options to find ways to construct plants which are more resistant to drought. And there was many different examples on all different kind of levels. We hear that, closing the gap between the soil and the roots with mucilage the plant can benefit from that. We learned that maintaining growth under drought can be profitable for the plant. That the architecture is important, the root angle, that also where the plant is actually sucking up water. We learned a lot about conductance, how the plant with the aquaporins, how the plant is controlling the flux. And then also what 16 says, we have also possibilities how plant can save water by establishing the canopy in a very certain manner, and also by regulating stomata. So we have really a nice toolbox what we can select from. But I think what is really very critical is that we really need to have a very clear understanding for the environment we want to construct a plant for. And it's also what you said, is that we have to know how are the stresses, about the intensity, the frequency of the stresses, how is actually also the spatial distribution of these stresses. And if you have this very clear in mind, this model, then you can go to this toolbox, what we learned here, and take, let's say, the traits. And then actually you select the method to measure that. And many times, and that's also an important point, and as a manufacturer of actually scientific instruments, many times we see that people buy a lot of equipment, measure tons of data, and then try to extract something out of it. And that is very expensive and very time consuming in many times. So I think that is something which is important. Another point I would like to mention, but actually because I was working actually on biotic interaction in my PhD, is something I was missing a bit. I don't know actually about the impact, but what I know is that, for instance, herbivory on plants has a strong induction of different phytohormones, which are triggering defense responses. Those defense responses strongly compete actually with carbohydrate for growth. So I know, for instance, that herbivory has a strong impact on root growth. So that might be something which should be considered. And what I was missing totally is, for instance, like mycorrhiza, arbuscular mycorrhiza. I don't know, I wasn't in the last talk, but I saw in the presentation there was something in there, but I guess that can increase actually also strongly the power of a plant to actually extract nutrients and water from the soil. So I'm very happy of my 4 days, and if I would be a scientist again, I think I would work on drought research. Thank you.
Probably notice a gradient on age, and I'm probably on that edge of getting past beyond that young scientist, so I appreciate your patience with that. I'm from DuPont, the private company, and part of the work that Mark have done, so I apologize if I have some bias on my statements in here. I would like to pick up from the statement about machinery and ability to phenotyping, also from Victor's earlier today talking about phenotyping. It's unprecedented, the capabilities that we have today about measuring and conducting or characterizing, whether it's environments, plants, or well, phenotypes and genotypes. I think what we didn't learn is how we'll integrate all that to make a sensible prediction. I think Mark provided a little bit of a surface or scratch the surface on some of the frameworks we are trying to put together. But certainly the opportunity is in there. Perhaps one way of thinking how we can progress or do things different or change a little bit of the paradigm is picking up again on Victor's presentation today, and Roberto talked about the phenotypic plasticity. Perhaps in my mind is not a novel concept or new concept. We have that since the early physiologists working with crop models. I think Graham can testify on that. Crop models are collections and fully integrated numbers and relationships of plastic responses to different levels of organization. So we have that. We need to figure out how we exercise and how we connect, how we utilize those frameworks to go from a genotype to phenotype. Since 1996, the Blue Book, there's a bit of work that has been done, but still we don't quite get it how to do it. So to me, there's a lot of learnings, and there's a way more excitement ahead on what is possible to learn. And to me, trying to advance that crop model whole genome prediction framework, advancing the statistical machinery, how it's essentially how we wire those genotypes to phenotypes, and how we utilize the information we collect, and how we develop those plastic responsive, functional responses, and how we come together in order to enable prediction, accelerate prediction, that in the end the breeders will be used to make better products. So that to me is at the core, and if you will, provide a number of organizing principles that guide our research. To me, the phenotyping platforms can generate data. Hopefully, we can think about those models to ask the questions: what is the data that we need, and how we allocate our resources. To me, there's a huge opportunity here to start going back to the basic biology, to develop those functional relationships and do less data crunching and more basic science, that then through the integration with crop models, it will translate into predictions to accelerate genetic gain.